Well, welcome. Welcome. This is a workshop of all three groundwater sustainability agencies in Sonoma County. I am hereby calling this meeting to order, and I'm going to invite chairs or board members from each basin up to give some opening remarks and introduce any members of the boards or the advisory committees from those basins that are present this evening. So I'd like to invite up Supervisor Gorin and Bruce Abeli-Amen from, Supervisor Gorin is from the Sonoma Valley Basin, Bruce Abeli-Amen from the Petaluma Basin, and Mayor Tom Schwedhelm from the Santa Rosa Plain Basin. Come on up. Oh, actually we have Supervisor Hopkins from the Santa Rosa Plain Basin, so come on down.
We have a wireless mic.
Hi, everyone. There it is. There it is. Thank you. Hi, everyone. I'm Susan Gorin. I'm the First District Supervisor, but for this purposes, I am the chair of the Sonoma Valley Groundwater Sustainability Agency. It's my privilege to introduce some great folks serving on the board. We're small but mighty and working well together. I know I saw Mike Sangiacomo representing the North Bay Water District on my board. Well, the cheap cheat, David Rabbit serves on our board. He represents the water agency. I represent the county. And the Valley of the Moon Water District, Ron Prushko. Ron, are you here? There you are, coming in. Welcome, Ron. And we do have the city of Sonoma and the, I'm missing the name, who am I missing? Vicki Mullis. Right. Yes, the resources agency. So those are our 6 members, and we have great advisory committee members, and of course I forgot my list. And give me my cheat sheet. Here it is. The advisory committee members, you can tell it's been a frantic day for both of us, so we're lucky we're here. And the chairman, Fred Alabach. Fred, I saw you. Where are you? There you are over there. Greg Carr, I haven't seen him, but he might come in later. Caitlin Cornwall's running a few minutes late. Vicki Hill, I know, there you are, Vicki. Jane Whitsitt, Jane, there you are, and Steve Wolf at my table. Thank you, advisory committee members and Jim Butchu. Yes, you're not on my list, so I've forgotten about you, Jim, but I see you over there. Thanks, Fred. I really appreciate the great collaboration that we have achieved in Sonoma Valley and elsewhere in our advisory committees working together and the board members working together. We are embarking on a new, innovative, wide world of groundwater, last in the nation to actually think about groundwater as an integrated resource. And it seems to be working very, very well. So I'm pleased to be working with Petaluma Basin, and I'm alternate on the Santa Rosa Basin. Apparently they think I have nothing else to do. So one of you.
Sure. Hi everybody, my name is Bruce Abeli-Amen. I'm the vice chair of the Petaluma Valley GSA. I'm doing this because I think David's running a little late. David Rabbit is our chair on the Petaluma Valley GSA, and Susan is on that as well. And Carolyn Wassam from the North Bay Water District, I think she said she's coming, but maybe running late. I think all of our advisory committees members are here. So raise your hand. Chairman Andy Rogers, Heidi Bauer, Clayton Engstrom, all right, Gary Mickelson, Rebecca Ng, Lindsay Strain. Now I call that a great advisory committee, 100%.
Also thrilled to be here tonight, and great turnout. I think it's really important for all of us in terms of the 3 different GSAs to come together, and I always appreciate the opportunity for these learning sessions. Feel like I'm back in school, but in a very, very good way. So I want to acknowledge my fellow board members. We have Vice Chairman Tom Schweidhelm. So if you want to stand up or wave, whatever you want to do the wave, do a little, yeah, there we go. Board Member Susan Harvey, I saw. Board Member Evan Jacobs. Where are you, Evan? You're in here somewhere. I'm running a little bit late. John Nagel, I saw you just come in. Wonderful, in the back there. And then Shirley Zane is also on our board, and I have not seen her here. Is she not here? Might also be delayed. And then I also want to give a huge shout out and thank you and gratitude to our advisory committee members, and actually introduce our chairman, Bob Anderson, vice chair, Rue Furch. We've got Sebastian Birch. Is he here somewhere? No? Okay, Elizabeth Cargay for Windsor. And then we also have Wayne Hayden, Craig Scott, and Marlene Soyland. Is Marlene here? I don't see that. But thank you all so much for being here and looking forward to the presentation.
Thank you all. I'm so excited about the table talks and the discussions.
Well, thank you very much for those warm words of welcome. I will share a few logistics before we launch into our program. The first is, maybe most importantly, there are snacks in the back of the room, so please feel free to get up and help yourselves. Restrooms, men's is to this side of the stage, and women's, actually you have to go back behind the room divider, and it's back in the back corner. This meeting is being video recorded, so if you're making a comment or asking a question, please ideally speak into a microphone during those question and comment times. We will have this microphone available. Otherwise, please make sure to speak loudly and clearly. If you're asking a question, perhaps the person answering that can restate your question if it wasn't heard clearly, so that we can capture all of that on video. We do have time for a number of different kind of question and comment formats. We have a moment, right after this, we'll have a moment for any comments that are within the jurisdiction of the GSA, but are not about items that are specifically on the agenda of this meeting. Hopefully you all have an agenda that shows the various recharge topics. So we have that opportunity for public comment. For questions for our speakers, we are asking that we just hold all of those questions till the end of the presentation so that we can get all the information and have kind of more of a comprehensive discussion. But because it is a public meeting, if you do wish to make a comment on any of these agenda items, I will announce a time when you can make that comment at the end of the item. Again, if you can, as much as possible, if we can hold the discussion to the end, I think it will flow smoother. So with that, I think I will ask if there's anybody here who wishes to make a comment on any item that's within the GSA's jurisdiction but is not specifically on this agenda. Okay, great. Well, then it looks like we're moving ahead of schedule here. I will then move right into our agenda. We have a few speakers before we move into our Q&A and our tabletop discussions. And so our first speaker is Marcus Trotta, who is the principal hydrogeologist for Sonoma Water's Groundwater Resources section, where he manages the technical aspects of developing groundwater sustainability plans for the Santa Rosa Plain, Petaluma, and Sonoma Valleys. His work involves leading feasibility studies for enhanced groundwater recharge projects, groundwater recharge potential mapping, and field and modeling assessments. His role at Sonoma Water also includes investigating the interaction and exchange of surface water and groundwater associated with Sonoma Water's riverbank filtration system along the Russian River. Welcome, Marcus.
Great. Thank you, Valerie, and thank you all for coming out tonight. It's a great turnout. Everybody hear me okay? Great. So what I'm planning to do, I've kind of framed my remarks to kind of address and provide some information around some general questions regarding groundwater recharge that will hopefully provide some context to what you'll hear from the speakers after me that'll go into a little more detail on some specific initiatives and projects. And so I'll be kind of starting out with some of the science behind groundwater recharge and how it relates to the Sustainable Groundwater Management Act, or SGMA, to kind of address kind of what is recharge and why do we care about it. I'll then provide a few kind of high-level examples of different scales of recharge projects to give you a sense of how we can either preserve or enhance recharge, and you'll be hearing a lot more of that from our next two speakers. And then I'll conclude by laying out some of the challenges we have in this region with respect to getting water into the ground and recharging it, and some of the work and tools that we have to characterize where recharge is occurring, how much is occurring, that can help us guide us in advancing some recharge efforts. Let's see. Okay. Maybe this needs to be turned on. That's usually what happens to me. Yeah. Okay. So, but first I wanted to kind of take a brief step back and just kind of highlight the importance of groundwater in our region. Groundwater makes up roughly 50% of the water supplies in each of these three groundwater basins that we're managing today. And those supplies can vary by basin to basin slightly and from year to year. Other important sources of water supply include Russian River, water from the Russian River system that's brought in by Sonoma Water and delivered to many of the cities and water districts in the basins, as well as other local surface water sources from those basins. And then recycled water is also a valuable resource that helps provide water for crop irrigation, landscape irrigation. But we're kind of focusing on groundwater. And groundwater represents a really important supply for many of the users and uses within all three groundwater basins. It's often the only supply for agricultural, for farmers, agricultural users, rural residential users. It represents the only supply for the city of Sebastopol. And it also represents a real important supplemental or backup supply for many of the cities and water districts. Groundwater also plays a really important role in service to the environment by providing flows to creeks and streams and wetlands in all of our basins. So it's a really important resource for us here in Sonoma County. So starting kind of with some of the basics on groundwater recharge processes. This diagram kind of shows us a cartoon of kind of a typical groundwater basin to kind of familiarize you with some of the terms and concepts that we'll be talking about. Like many aspects of our groundwater basin, this diagram shows a basin or valley that's been filled with sediments, sands, gravels, silts, and clays, where groundwater is stored and flows through. And it's surrounded by hills or mountains that are made up of kind of fractured rock that are also connected to that groundwater basin. Now, when rain falls across this landscape, a large part of that water goes directly to run off to the nearest streams and creeks. Some of that water will kind of accumulate in puddles or get evaporated straight back into the atmosphere. And then what kind of doesn't do those things will infiltrate into the soils, and how much infiltrates is a function of, what types of soils are there, whether they're sands or clays, will dictate how much of that water will infiltrate versus runoff. Some of the water that infiltrates into the ground doesn't actually make it to an aquifer as recharge. It'll get intercepted by the roots of plants that use that water as a water source, and that water then gets evapotranspired back out into the atmosphere and goes back out of that groundwater system. And additionally, in some areas, water will get kind of bound up in the shallow layers of our soils. We have a lot of clays here in Sonoma County, and that can trap water from reaching those aquifers. And so there's definitely a distinction between infiltration and recharge, and so that's something I'll come back to a little bit later. The other thing I wanted to point out is that This diagram shows a few different types of our mechanisms of recharge that I'll be talking about. One is kind of distributed recharge, and that's recharge that occurs kind of throughout the landscape, water that infiltrates throughout the ground surface in the basin, depending again on the soil types and things like that. Another important form of recharge is stream bed recharge. Our stream beds often have sands and gravels at the bottom, and those make for really good recharge locations. That's also where a lot of water accumulates, so those can be locations that provide a lot of recharge to our basins. And then a third type of recharge is called mountain front recharge, and that's recharge that originates up in the highland areas and kind of moves through either fractures or some sort of channels in those mountains, and then can enter our groundwater basins kind of from the sides of those basins. And that's also another important form of recharge in our basins. Once groundwater recharge occurs, that groundwater moves through our groundwater basin, our aquifer systems, until it's eventually discharged through either wells or through streams and wetlands. And that groundwater movement and travel can occur over pretty wide time scales. It can vary from days to years if that recharge occurs near a stream or a wetland, or be on the order of centuries to thousands of years if it's traveling through the deeper portions of the aquifer system. So the time scale of groundwater is something that's really important to take into account when we're trying to manage it. It's not something that it happens one year and you see the results that same year often. So taking some of these concepts to an example for our local groundwater basins, this is kind of a conceptual diagram of the Santa Rosa Plain. If you can imagine taking a slice across that basin and taking it out and looking at it. This is a kind of a conceptual cross-section, and it shows the different geologic formations. We have a clay-rich Petaluma formation, a sandy formation on the western parts of the basin, the Wilson Grove formation, volcanics in the hills underneath Sonoma Mountain extend beneath that basin. And you can see the kind of the flow paths that we illustrated before. And we have all three of those kind of recharge mechanisms occur in all three of our basins to varying degrees. Infiltration occurs throughout the landscape and in the valley areas, along streams as well as along the mountain fronts. The other thing I want to point out in our basins, unlike some other basins such as the Central Valley or Southern California, where you have these big sandy basins that are filled with lots of sands and gravels, we have a lot of clay. We also have a lot of geologic complexities that make characterizing recharge pretty challenging, and as well as finding areas where recharge can actually occur and make it to the deeper aquifer systems. So moving on from some of those natural recharge processes, the other kind of reason that recharge is particularly important for us right now is a state law that came into effect back in 2015, the Sustainable Groundwater Management Act, or SGMA. And it, for the first time, requires management of our groundwater basins throughout the state. And it actually presents a lot of opportunities for recharge. In Sonoma County, we have the three basins that you are all sitting at the tables of: Sonoma Valley, Santa Rosa Plain, and Petaluma Valley, that are required to comply with this law. And what that means is that each basin had to form groundwater sustainability agencies by 2017. That deadline was met, and these agencies, who you've heard from the boards of those agencies already, have been functioning for the last 2 years or so, and are in the process of meeting the second goal, which is to develop groundwater sustainability plans by January of 2022. And I'll provide a little information on what needs to be included in those plans. And those plans need to demonstrate how we're going to achieve sustainability within 20 years or by 2042. If we fail to meet any of those deadlines or requirements, the State Water Resources Control Board would intervene and kind of do our management for us until we're able to meet those requirements on our own. and that intervention would come with pretty significant assessments of fees to well owners in those basins. So the groundwater sustainability plans that we're currently working on have kind of four main components. The first component, which we're working on now, is the description of the basin conditions or basin setting that describes the geology, water quality in our basins. The next step is to actually set the sustainability goals in the basin, and that's something we're just starting to do right now, and that dictates what types of projects and actions that we'll need in order to either achieve or continue sustainability in our basins. So recharge kind of fits in right now, where we're describing what we know about current recharge conditions, and then it'll also come into play as we develop these projects and actions that'll be needed in each of these basins. As I mentioned, the plans are due by January of 2022 and need to demonstrate that we'll achieve sustainability by 2042. So how do you define sustainability? That's kind of the big question, and the Sustainable Groundwater Management Act defines it as needing to locally define kind of thresholds that will that'll avoid your basin experiencing undesirable results for any of these 6 sustainability indicators: the lowering of groundwater levels, seawater intrusion, reduction of groundwater and storage, land surface subsidence, degraded water quality, and surface water depletion. And we really see recharge as potentially helping out meeting all 6 of those, depending on basin conditions. But really kind of these 4 are ones that we see as being most likely to be positively affected by recharge in the basins. That's sustaining or helping to raise groundwater levels, preventing the loss of groundwater and storage, limiting or offsetting surface water depletion, and then preventing seawater intrusion in the 2 basins where that's an issue. Obviously, that's not going to be an issue in the Santa Rosa Plain, which is not connected to the ocean. However, it's important to understand that not all recharge efforts are going to provide a benefit in terms of SGMA compliance. So we'll need to consider things like the amount and location of the recharge relative to where our criteria are set and what our criteria are that we'll be establishing over the next year or so that'll go into these GSPs. And then we'll also need to consider areas where infiltration doesn't actually reach an aquifer or contribute to stream flows. So just a few examples of types of recharge projects, and again, I think you'll hear more of a lot of these. On-farm recharge is something that's being explored quite a bit in the Central Valley, and you'll hear about some initial efforts here in the Santa Rosa Plain by Dr. Bachand. Kind of large-scale percolation ponds are something that have been in place in many areas throughout the state. This is a pond in the Santa Clara Valley that recharges state water project water to help sustain groundwater levels in that basin. And then just kind of the, preservation of open spaces that overlie recharge areas are another way to preserve recharge. One other technique that we're not going to really be talking about here today, but I wanted to let you know about is more groundwater banking or aquifer storage and recovery, where you can actually use winter water, surface water, and recharge that through wells and store it underground. So this is more of a groundwater storage type of project, but it's something that we're also investigating in these groundwater sustainability plans. Small-scale recharge efforts can also provide a benefit to a basin if they're done in the right areas and if they're distributed in enough areas of the basin. There's a lot of information on how landowners can do things on their lands to promote groundwater recharge and reduce runoff. The cities have a lot of low-impact development programs and information on how to do that. Your local RCDs, Resource Conservation Districts, have a lot of great information here on the table here today on how you can do rainwater harvesting and improve your landscape to promote recharge. Let's go back. And so, doesn't want to see that slide. So we have done a fair amount of assessments, and we've done some site-specific investigations of potential recharge sites in many of the basins. And one thing that we've really learned is that location is really important. As I mentioned, we have a lot of clays, so trying to identify areas where those clays may be absent and we have some more sand channels is really critical to that process. And so some of the techniques that we have and some of the tools that we have available to look at where recharge might be feasible in our basins kind of start with doing some kind of desktop analysis with available data sets. And this is an example of data sets that we've combined to give us an idea of where recharge might be more prevalent in our basins. And so we can take a map of soil conditions and add it with underlying geology and other information such as topography to produce maps of potential recharge areas. This is a potential recharge area map that we developed in Sonoma Valley with the help of the Sonoma Ecology Center. And it's kind of a first cut glance at where recharge may be occurring. The maps on your tables today are actually these soils maps. We included those because those are maps that we have that are the same for each of the basins. And they provide a really good first cut at where recharge may be feasible in our basins. With that information, you also need to look at potential constraints, such as areas where there's shallow groundwater, and then also include other information that we have available, such as stream flow data, groundwater quality data, that can also provide us some insights as to where recharge is occurring. We also have tools in each of our basins, computer groundwater models that we can use to simulate where recharge is occurring, identify to what degree recharge is an important component of the water budget, and then we'll also be using these models to scope out projects and assess how they can help us meet the requirements of SGMA in our groundwater sustainability plans. Another tool we have is in Sonoma Valley. We've been doing studies of stream flow recharge using a technique known as seepage runs. Due to time, I'm not going to go into detail on these, but they can provide indications of what reaches of streams are are your recharging reaches essentially, and what reaches of streams are gaining streams from groundwater flow. By taking a bunch of stream flow measurements over a short duration of time, you can get a pretty detailed look throughout your basin as to what streams might be contributing recharge. And here in Sonoma Valley, we see kind of the Carriger Creek and some of the upper reaches of some of these other creeks near the city of Sonoma look to be good recharge locations. Once you have an idea of where you'd want to do a recharge project, depending on the scale, if it's a fairly large scale project, you're really going to want to go out and do some site-specific investigations, actually look at the soils and geologic units around the site, drill some borings, examine soil cores, and maybe do some test pits and infiltration testing before really designing a larger scale recharge project. Another technique that's used is geophysical investigations. This is using electrical resistivity. We've done these at a number of sites in all three basins. And the advantage of this is that you get a pretty good picture of kind of the three-dimensional aspect of the subsurface, and it could really help you find areas where you may have sand channels that are really hard to see if you just were to drill one boring or two borings at this site. You might miss areas where there's really good opportunities for recharge. And lastly, the other information sources that we rely on and that could be really beneficial is just community information at gatherings like this, or going out in the field and talking to farmers or other landowners to get information as to where they see water percolating into their landscape and how that relates to our maps of different soil types and geology. This last slide just kind of gives you a snapshot of the type of information we have in each of the basin. That kind of varies by basin to help support where recharge may be occurring. And you can see in Sonoma Valley, where we've been doing voluntary groundwater management for a while, we have a fair amount of information, as well as Santa Rosa Plain. Not as much in Sonoma Valley, where we just started a USGS study in that basin a few years ago, and so we're still working on catching up there, but we are filling in a lot of those information sources as we develop the GSP. So with that, over time, so I'll turn it over to, I think, Kamyar is next.
Thank you very much, Marcus. That was a great overview to kick us off. Before we move to the next presentation, is there anyone who, I'll remind you, we're asking to hold questions till the end, but is there anybody who has a burning comment that they want to share about that presentation? Okay, it looks, I see one. Okay, can you come forward, please, and I'll hand you a microphone. I think for questions like that, I'm going to ask to hold the questions till the end. I know it's a little bit confusing because this is a public meeting. We need to make sure we're providing the opportunity for comments on each item, for comments that folks wish to make, but for questions, we're holding those to the end. So I know it's a little confusing, but we're trying to dot the I's and cross the T's. So it looks like we'll make sure to get to that question at the end. Doesn't look like we have any other comments. And so we will keep moving. I'd like to introduce Kamyar Guivetchi, who was appointed a division manager at the California Department of Water Resources in 2008. During his 41 years with DWR, Kamyar worked on technical studies and planning projects with statewide integrated water management, North Central Region Office, Division of Planning, Bay Delta Office, and Division of Environmental Services, managing the Sassoon Marsh program. For the past 19 years, Kamyar managed staff work and coordinated the collaboration of numerous government agencies, Native American tribes, stakeholders, and public to prepare the California Water Plan updates 2005, 2009, 2013, and 2018. Wow. He chairs the 30-member State Agency Steering Committee and is the state co-chair of the California Biodiversity Council's Executive Committee. Kamyar has a Bachelor of Science in Civil Engineering, completed postgraduate work in Environmental Engineering at the University of California, Davis, and is a California Registered Civil Engineer. So welcome, Kamyar. Thank you for being here.
Good evening. Thank you. I appreciate the intro. And for those of you who may not know me, my mantra is connecting dots. My passion is bridging silos, and my superpower are rose-colored glasses. What I'd like to do this evening is to share with you the work DWR has been doing in partnership with a number of other folks over 2.5 years on what we call flood managed aquifer recharge. And as I go through this, please, I want to emphasize the word flood is as important as managed aquifer recharge. And to kind of set the context, you know, California water is a tale of extremes. Rarely do we have average water conditions, and we're either in the high flow or the low flow conditions, and in some years we can have a flood and a drought at the same time. Climate change is making those extremes more frequent and more extreme, dramatic, and more consequential. In particular, the changes that we're experiencing in our snowpack, which is currently our largest surface reservoir, is already being observed and will continue as the impacts of climate change are felt. And this is a plot of outflows from a climate scenario simulation for the American River. What you observe here is also true in many other major river systems in California. What you see is a water year and 120 years of simulation. And the lines that are the bluish gray lines, those are the first 30 years of that period, starting in 1980, which was historic conditions. And the amber brown lines are the last 30 years, basically 2070 to 2100. And the point of this plot is to show that we expect to see a dramatic shift in our runoff patterns in major California rivers. And most notably, we're going to experience higher peaks in the winter months because we're going to get more of our precipitation as rain than snow. And almost as dramatically and consequential, we're going to have less runoff in our rivers during the summer and early fall months. The other thing that we wanted to really emphasize in the 2018 update of the water plan, and I love props, so I've brought a number of handouts, one of which is the 2018 water plan update. And we can certainly, we do describe many of the critical challenges that California faces in terms of water, but we also wanted to point out that dealing with those challenges is very difficult in terms of some systemic and institutional challenges. We have a very decentralized way of making decisions about water in California. Over 2,300 entities have something to say about water, flood, wastewater, water quality. That also spills over in the way that we do our regulations, which are siloed and sector-specific. And when you try to do multi-benefit projects, it becomes very difficult, time-consuming, and sometimes not doable. We also, to do more multi-benefit projects, are going to need a lot better data and access to the data that we already have, but that are as siloed as our institutions are. Funding is always a challenge in trying to overcome or resolve the problems that we have. And then spending money is one thing, but demonstrating to the public the return on investment is another. And so we have to do a much better job of tracking the outcomes of our investments, not just how much money we spent and what projects we completed. This flower diagram is intended to represent the main water sectors in California. And traditionally, and even today, most of the activity of the sectors are in the outer periphery of the petals of this flower, where there's little or no overlap. To move toward a more sustainable way of managing our water resources, we have to get our water sectors to work more toward the center of this flower, where we get more overlap and synergies. And that's what we mean by integrated water management. And to get there, we're going to need big collaboration. We're going to need our agencies to align their work much better than now. And we're going to need our water sectors not just to coordinate and collaborate, but to co-manage our water from headwater to groundwater. And FloodMar really epitomizes this approach to move toward the center of the water sector flower. And again, what we mean by floodmar is the use of higher flows for the purpose of groundwater recharge, aquifer replenishment, using agricultural working lands and managed natural lands. And I'm going to talk about how that can work from headwater to groundwater. Floodmar has some unique attributes. One is that to make it work, it has to be a voluntary program, public-private partnership. The Corps of Engineers, as part of their flood study, did a study in the early 2000s. They called it conjunctive management for the purpose of flood protection. And this was the first time that I had seen where the flood folks had looked at groundwater as a way of reducing flood risk. And they showed that in the Central Valley, just by reoperating the rule curves in our terminal reservoirs, we could get on average 1 million acre-feet more water yield than we do today. Where they kind of stumbled was they said, well, the way to do this is we'll just buy up lands and we'll make them recharge areas. Well, that didn't go over too well with the Farm Bureau and the landowners, and that's why floodmar really has to be a voluntary public-private partnership to work. The other neat thing, which was already mentioned, is it can be done at multiple scales. It can be done on a single farm, and it can be done on an entire watershed. And one of the things that we are beginning to demonstrate is that the larger the footprint that we implement floodmar, the more benefits it will provide us. The other thing on the next slide will demonstrate it even better is that it's multifaceted. There's not just one type of floodmar project. It's actually an approach, a strategy for managing water. And also important, it's an underutilized part of our water portfolio. We built levees to keep our flood system separate from our groundwater basins. Now what we have to do, because of climate change and the dramatic change that we're going to see in the way we get our runoff patterns, we're going to have to manage water across those levees to reduce flood risk while at the same time recharging our depleted aquifers. So again, taking this headwater to groundwater approach, there are many types of projects that can be part of a floodmar approach. One is called forecast-informed reservoir operations, to actually see when that next storm pattern is coming in, to be able to draw down our reservoirs and be able to capture more of the next flood peak, both to reduce flood risk as well as recharge our basin. The other is to actually have conveyance facilities that can move water from the higher peak flows in the streams to working lands for the purpose of groundwater recharge. It's already been mentioned, to do that, we're going to need better information about where the good recharge, better recharge areas are, and we have to figure out how do we compensate landowners to bring an incremental decrease in flood risk, or to provide ecosystem benefits by ponding water on habitat, or to improve flows in the stream as we improve the groundwater elevations in our aquifers. Another document, we don't have the entire document, but Chapter 5 is here. It's the white paper that Department of Water Resources put together with a number of other folks last year. And in the floodmar white paper, we identify a number of public benefits that can be realized doing floodmar. The ones that have stars next to them are the ones that the Prop 1 Storage Investment Grant Program identifies as having public benefits. Conspicuously, aquifer replenishment doesn't have a star next to it. And the reason is that bond chapter was written before SGMA. So now with SGMA, we really need to begin recognizing aquifers as natural infrastructure that would make it eligible to provide public benefits in future bond measures. In the white paper, we also identify a number of implementation barriers that project proponents have already identified. DWR did not invent FloodMAR. FloodMAR has been going on for 20, 30 years on small scales, and project proponents have identified a number of these things that need to be worked out. The other good news is that the state of California is beginning to recognize FloodMAR as an important strategy for implementation. One is that the Central Valley Flood Protection Plan of 2017 identifies this not by the name FloodMAR, but by the type of strategy. We also did a system reoperation study at the Department of Water Resources, and the information that I'm presenting you today is part of phase 4 of that system reoperation study. We basically demonstrated that the existing water infrastructure in California is fairly optimized already, and we can't get a lot more out of it unless we begin to do much more aggressive conjunctive management of our surface and groundwater as described in FloodMAR. The State Board of Food and Ag sent a letter of a dozen recommendations to Governor Brown identifying ways that the state of California, state agencies, can begin to help support the implementation of FloodMAR. And in the 2018 Water Plan update, of the 19 key recommendations, FloodMAR is one of them. So the state really considers this an important part moving forward. I'm not going to read all these bullets, but this is a list of the kinds of activities that DWR has undertaken over the last 2.5 years. We've put together the white paper, fact sheets, a number of them that are here today. We are currently in the process of completing a watershed study in the Merced watershed and the Tuolumne watershed. And this is taking that headwater to groundwater approach where we're working with the local entities to link together their surface and groundwater models to see what potential they can have in that watershed for doing FloodMAR. And the other really important part of these studies is that we are doing a climate vulnerability assessment first to actually show what the flow patterns are likely going to be in that watershed in the future, and then look at how FloodMAR and other strategies can help that watershed adapt to those vulnerabilities. So if there's one thing that we're looking for are other partners on major river systems throughout California to do similar climate vulnerability assessments, and then these FloodMAR and adaptation studies. The folks in the Merced watershed have already begun to formulate projects that they could do in their watershed to help begin that adaptation process. The other thing that we have done is, remember I mentioned there are all these implementation barriers. We have convened a research advisory committee at the, including, and I'm going to get to that right now, 100 organizations, 200 experts work with the Department of Water Resources over 1 year to put together a research, data, and development plan. One of the handouts here is a fact sheet that shows the list of the organizations, and these folks working together identified 13 research areas, and those are listed in the middle of this brochure. And then we asked them to identify the data gaps. They identified about 130 data or information gaps for FloodMAR, and then we asked them to prioritize the top 3 for each of those 13 research areas. One of those research areas is what we just heard about, aquifer characterization. How can we get better information about the recharge potential of our various watersheds and groundwater basins? And then we mapped those 39 research and pilot project ideas into 8 implementation factors. One of the handouts there is a chapter from the white paper that describing those 8 implementation factors. This is basically a checklist on if I want to do floodmar in my watershed, what kind of things do I need to consider as we develop the floodmar projects? And then all of that went into the R&D plan. One of the things that we're really advocating for academia in California, universities and colleges, national labs, is consider the 39 studies for graduate student projects and basically get our universities feeding into and supporting the implementation of floodmar. One of the most important recommendations that came out from the Research Advisory Committee is let's not make this a one and done effort. Let's put together a floodmar network so that these 200 folks plus others who are interested can continue to exchange information into the future. So how can the state of California help advance floodmar? The California Economic Summit has been working on water issues for several years. One of the handouts are the key recommendations that was presented at the Fresno Summit in November, identifying these kinds of recommendations. So one of the really important things is to begin recognizing aquifers as natural infrastructure and the replenishment of degraded aquifers as a public benefit. That will then open the door to getting state funds, public funds, to help cost share the implementation of floodmar and aquifer recharge projects. Really helping to advance these multi-benefit partnerships across the state. And then you may have heard that in some areas of California, even with all of the adaptation strategies that GSAs may be able to implement, there may be some lands that still will not have enough water to continue the level of cultivation there today. So one of the recommendations is let's not talk about these lands as fallowed or retired, which implies they're lesser in value. Let's talk about repurposing those lands either for more healthy soils operations, rotating crops, or making an environmental account underground where the fish protection community could pay landowners under high flow conditions to store water in their groundwater basin that they would then use during the next dry period instead of diverting that water from the nearby stream and leave that in the stream for fish. And there are other, maybe taking some of that land and making it into ecosystem restoration projects. So let's see how we can keep landowners on the land and repurposing that land use it's kind of like the public option concept. So this slide is just intended to note that to really scale up floodmar in California at a watershed scale, everyone has a part to play, including state government, by providing technical assistance, financial assistance, and even some regulatory streamlining and alignment. So if we want to do multi-benefit projects, we need regulations that can actually help promote that work going forward. And that's intended to say that this is a moonshot. This is as much about sociology and psychology, getting water sectors and institutions and organizations to work together to really make this work. And it's not a voluntary thing, because if we don't do this, we may not have a plan, but Mother Nature does. And we will get those flood events, those fire events, those extreme drought events. So this will help us get out in front of it. Thank you.
Thank you very much, Kamyar. That was great. I am sensing the theme that everybody is on board with holding all of the discussion. So if nobody raises their hand saying they wish to comment on this particular item, we'll keep rolling. Great. And then I am pleased to welcome Dr. Philip Bachand, who is President and Principal Engineer of Bachand and Associates. He has a PhD in Environmental Engineering from UC Berkeley and has been focusing on water resources and water quality challenges at the nexus of California agriculture, water, and the environment for over 20 years. He has pioneered on-farm recharge, the flooding of agricultural lands to recharge groundwater, and is project director for the McMullen On-Farm Flood Capture Expansion Project in the Kings Basin, a regional conservation partnership program project. He is furthering the science and engineering on farm recharge and developing strategies throughout California for areas working for groundwater sustainability solutions under the Sustainable Groundwater Management Act. Welcome, Phil.
Thanks, Valerie. Can everyone hear me okay? So, as a PhD and a small business owner, let's see, I'm reserve the right to contradict people. So I respectfully disagree with Kamyar Guivetchi's statement that Floodmar has been going on for decades. The flood in Floodmar has been going on for decades, and the recharge in Floodmar has been going on for decades. But the actual managed part of it has not been going on for decades. And I say this because the project one of the projects I'm going to talk about, that we conducted in Central Valley, is the first on-farm recharge project, and was recognized as that through our grant from the NRCS. And that really represented sort of the first paradigm shift in recharge. I mean, Kamyar has gone through a lot of these statements about what Floodmar is. He talks about scalability. He talks about headwater to groundwater. He talks about strategy and systems and and flexibility and all this. And all those things are true about this approach, and were really not being considered prior to 2010 or so. I mean, there is that core paper that he talks about, and I've seen that too, and that really went nowhere. And so I'm going to talk a little bit about this, and there's a lot of acronyms that are used in the sort of the Floodmar bucket. On-farm recharge is one. UC Davis will talk about AgMAR, Agricultural Managed Aquifer Recharge. Santa Cruz area, they talk about a stormwater recharge. And here, the acronym we've talked about in my partnership with Jackson Family Wines has been recharge above use. And this is recharge above annual groundwater use by agriculture at a site. So this is all about recharge. And in this case, what we're trying to highlight is that we're trying to recharge above the groundwater use that a farm would have. So I was going to answer these 4 questions. I've been doing a lot of projects over the last decade, and I was going to talk about what this looks like. What are our key findings from our work at Sara Lee with Jackson Family Wines over near Mark West Creek? Where are we going from there, meaning the people I'm working with and myself? And what are critical challenges that we face, that we see the region faces as well? So I was going to talk about this first one first. And so the reason people are looking at groundwater recharge for surface water and for just basically water supply is because of its cost. It's lower cost, let's see. I know there's a button for light here somewhere, yeah. It's a lower cost than any of these other options. And this is the nice work that Water in the West did out of Stanford, and I've been showing this slide since about the time they put it out. On-farm recharge and these agricultural recharge projects are really at the lower end of this cost. The McMullen one that that Valerie mentioned, we're looking at it being somewhere in the range of about $50, $60, $70 an acre foot cost. So that's and it's important to know that when we talk about recharge and floodmar, what we're really talking about is a better integration of our groundwater and surface water systems. So historically, California has had this system in which we capture our surface water, we release water as fast as possible from our watersheds so that we don't have flooding. That's the old paradigm. Release it as fast as possible because you were worried about flooding downstream, and get it off the property. And what the floodmar approach is instead of trying to release it as fast as possible to reduce flooding, you're trying to hold it back to manage flooding so that you can recharge to groundwater. And you need a system that is expandable and scalable and fast in responding to these releases of surface water, that whether from climate change or just normal climate conditions that we've had, worse under climate change, but we've always had them, and they're getting worse. You need to be able to act fast, and with it's not as important here with the snowpack, obviously, but in the Central Valley, where your snowpack is, where they get all their water from snowpack, they need to respond quickly, and we'll need to respond more quickly as water comes out of the mountains faster and faster. And you will have a similar condition here, where your water is coming out of your mountains faster and faster as well, because your storm events are going to be bigger and bigger. So this was the CIG project that I talked about earlier. This is done in 2010 to 2012. God did us a favor that year. We put this in, and He provided water. We have flooding here. You'll see this image in a lot of work that in paperwork on floodmar, but He provided us this big storms. We did a study. The idea, is to capture these events, and this is a fairly typical representation of what California rivers look like. Everything's over the during a 30, 40-year period. Everything's fine. There's a lot of dams holding back the water. Then bang, it hits, and that water goes through, and you got to somehow figure out how to capture it. And so the idea with this whole approach is having it be scalable, be able to expand with private lands, and you want to design this management into the farm system. Come on. Oh yeah, okay. And this is just a rate that we had. This is what the McMullen project looks like. This is all three phases that we have. This is the first phase here that is being completed right now, and it's about 6,000 acres. It's along the Kings River. And then we have the second phase, which we're working on right now. It includes it includes a capture system near the river. It includes conveyance. It includes fields that we can store water on, captured water on. Come on. And this is our recharge on the project in 2011, where we had recharge in the late winter, and we carried that recharge into early May. So it wasn't continuous. This recharge event occurred early when we had water coming out of the Kings and was about 20 days. And then this was the tail end of an event that went for about 40, 50 days. And you can see that we started having the vineyards leaf out. This is what the kind of equipment you would see if you were doing it. and sort of characteristics, you see that you need temporary pumps and temporary motors to move the water. You would see increased wildlife use of your property. These are little feet of wading birds, footmarks of wading birds. You need to be collecting some data on it, and you need to be recording the data on it. These are all going to be needed things as you move into this world of Sigma, where you need to be keeping accounting of what you're doing as far as recharge and what is happening with regard to regional water budgets. This is a more recent project that we're working on. This is not the actual project. This is some land in Colusa County that we're partnering with Pacific Gold on. We have a project with them down in McFarland, but this is their land up in Colusa. And they have pecans located right along the river, Sacramento River. And in June 2017, this is what they look like. And in July 2018, this is what they look like. These pecans they obviously suffered a yield problem this year, and they were young trees. But this year, July 2018 and that 2018, they were fine. So some crops are really well suited for recharge. Pecans, walnuts, vineyards, all being amongst those possible crops, as well as row crops and fallowed lands, of course. And then this is the pecan orchard down in McFarland, which we're looking at, and we're doing some data collection here. We're looking at this instrument. This data logger is monitoring for root zone oxygen levels, as well as moisture content and soil and salts, to see the effect of these extended periods of flooding on the health of the crop. And you can see that this is kind of how, flood mark kind of looks sometimes. We're not necessarily talking about putting feet of water on a system. We're talking about just sort of spreading water across in a way that you can do recharge. Now this is a low level of water. These fields are all graded, and so you might have it be high at one end and low at the other end. But you're always trying to kind of keep it kind of shallow. And then this is a pipe that we put a flow meter in, that we connected to flexible piping so we could measure our distribution of water to the different fields. And then, I don't know if this will play, this is a silt fence that we put up as a way of holding back water in this field. And if you watch this enough times, you'll get car sick. But the idea that we're trying to show here was that we were, with a simple installation of a silt fence, rather than putting up a berm or something, we were able to hold water back in a field and kind of spread it further back. The effectiveness of all these recharge approaches is being able to have a larger area of coverage, as well as good soils that will take it. Okay, let me go back one. I guess I won't go back one. Yeah, back. Okay, so then what are key findings from our vineyard studies? So, can you advance it? Okay, so this is Sarah Lee field, and advance it one, please. And so this is the field, and these red arrows are groundwater wells that we put up at Sarah Lee. So we were doing our we were doing our recharge on field 3, and field 4 and field 2 are controls where we were doing no recharge. These locations are where we had soil moisture probes. Here's where we had the groundwater monitoring. We have it here, 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 and here. And then we had some stream monitoring this little ditch here, as well as monitoring in Mark-West Creek. And so the goal of this monitoring was to be able to see, well, these moisture probes were to see effects on shallow groundwater and shallow soil moisture in the root zone. These were to see responses in groundwater. And this site was selected initially because it scored really high on the SAGB rating, and any of you are familiar with the SAGB rating, this is a good example. This is one in which the SAGB rating was really wrong. The SAGB rating is a rating that was put out by UC Davis to provide you an estimate of recharge, of your location's rechargeability. And the SAGB rating on this area was like good or something like that. And as was our site in the Central Valley. They were both the same SAGB rating, and the Central Valley site has an order of magnitude higher recharge. So really it's important. And the reason this is so different, one of the reasons is because we have all this, because the area here is very complex as far as the layering of soils that you don't have in the Central Valley, as well as the underlying geology, and as well as this having a kind of a high, people will talk about in this area deep and shallow groundwater, and this is sort of a perched groundwater area. So these wells that we put in are shallow wells, and they're measuring water in the top 40 feet below ground. And so we have one well that's deeper, a paired well, shallow and deep, where we are able to measure like water deeper down. And so when you talk about groundwater recharge projects in this area, you really need to understand that as simple as recharge sounds, of like just throwing water in a field and letting it recharge, the concept of actually getting it to do what you want and being able to measure it and account for it is pretty complicated. And so when Marcus talks about places that you can and cannot do recharge, that there is that. But then even where you can and cannot do recharge, it's like, well, how do you measure what you're doing on recharge? Because you have a lot of places water can go on these fields. They can flow out. This site here, we had in our very first year, which I don't show any data from, we put up some little barriers here in this channel so that we could spread water across these fields. And Marquez Creek apparently jumped its banks and came along here and wiped it out. And so there's all these kind of complexities in trying to implement this approach that shouldn't dissuade you, but you should go into it knowing that things are not, unfortunately, things are not as simple as you would hope they could be. These are groundwater gradients, and this is in the fact sheet. I won't spend a lot of time on this, but we have a very nice fact sheet on this project that's at the table for anyone. There's enough copies for everyone here. And basically, in a nutshell, we see groundwater mounding occurring from our groundwater recharge that is in excess of what they would normally have with the level of rain they had received to that point. And so we saw that. We see, importantly, so you can see after our recharge, we have flow, a groundwater gradient that goes towards Marquez Creek. And this is the year that we did recharge, and this is the year we didn't. And we were at a higher gradient by these amounts. Well, this and this are the two, and we're basically a foot to half a foot higher gradient the year we did recharge versus the year we didn't. And importantly, this is again, this is a sigma thing where you say, well, we're worried about groundwater, and which sigma goal are we trying to address? And in this situation, the sigma goal you're trying to address is improving your flows to your stream, Marquez Creek, and helping improve surface water conditions, because this is a perched groundwater table, and it's not really getting to the deeper groundwater. But that being said, addressing stream flows is very important in this region. So the next question is, and so here's some lessons learned from Sarah Lee. How am I for time? 1 minute. Well, yeah, so lessons learned from Sarah Lee, these are in the fact sheets, but RAU can be successful in vineyards. Shallow groundwater mounding can increase stream base flows, and increases in soil moisture can decrease irrigation demand. Importantly, implementation was successful using standard vineyard irrigation infrastructure, so impact sprinklers in reservoirs. This kind of approach requires that the people doing it understand the goals and objectives, because otherwise they won't do it correctly. And you need to have good data tracking. And I'm going to blast through the results. And you know, I'm losing like time with this. Don't I get like extra 5 minutes or something? And so this is the groundwater mounding I was talking about, and sort of this gradient. This is Darcy's law, and so you know you get an increase in groundwater gradient, and according to Darcy's law, which is up here, you get increased flows. And if you're in a losing stream condition versus a gaining stream condition, well, you're then going to lose it slower too, because you're raising your groundwater and you're decreasing the groundwater gradient away from the stream. We also saw, one of the things about this site is that doing the recharge raised our groundwater table, and it raised our perched groundwater table. And so what it did is it reduced the demand for irrigation in the area. So even though we weren't able to directly affect deep groundwater, we provided a mechanism for the irrigators to reduce irrigation so that they would draw less water from deep groundwater. So even in a perched groundwater condition, you can favorably affect deep groundwater if it's benefiting your water storage capacity in your root zone. And I'm not going to talk about those, I just did. Where are we going from here? I'm working with SAVE and Jack's Family Wines. We're working on a comprehensive program that includes RAU to enable vineyard owners to help address groundwater sustainability, self-funded, voluntary, helping provide SGMA compliance to the vineyard community. These are the different program elements that you can read here and what they affect as far as groundwater and surface water under SGMA. So injection wells they're working on. They're working on improved groundwater well monitoring, wind machines for frost protection. Those are all affecting groundwater. Surface water is being affected by the injection wells, by the RAU projects, utilizing soil moisture data and local weather to enhance irrigation efficiencies. That's a groundwater thing. Summertime releases from agricultural reservoirs for fish flows. That's a surface water benefit, and the Healthy Soils Initiative, which is a groundwater benefit. And there's probably some overlap between those. And then critical challenges. The only critical challenge I think I'm going to bring up today, well, there's implementation at scale. You know, you can do this on your little farm, your 60 acres or 30 acres, or Joe can do it, and Sally can do it, and Benjamin can do it, and if they're just doing it, and it's not being done at scale, it's not going to really get you very far. You need to be implementing this at scale to make it worthwhile. And so this is another thing about Floodmar, that you need these things at scale. And so to say that it's been going on for a long time, it's like, well, yeah, it's like your child who went to college. They've been around a long time. They haven't been contributing much for like 16 years, 18 years, and they finally went to college, and hopefully they'll do something, right? So that's sort of that's Floodmar, right? Floodmar has just gone to college now, and maybe in 2 or 3 years when they come out, they'll do something of value, okay? Costs and credits is an issue, efficiency and effectiveness, but in this area, a big thing is water rights and having water for Floodmar. So, there's water sources here. We have a lot of rain in this area, even in dry years. And you have 60,000 acres of vineyards in this area and other additional acres of farmland. So a lot of working landscapes. And if you're able to enroll those, and there's erosion control projects already going underway in these areas. So if you can enroll them and sort of keep an accounting of how much water they're capturing and storing, that's helpful. And that's free water. That comes directly from the bucket of God before it gets regulated by man. And then there's recycled water, which you'll need permitting for to use, but that comes directly from the bucket of man. And it's almost as good once it's been cleaned up sufficiently. You have to make sure it's good enough to permit. But those, getting your water from your rivers and streams is a water rights issue, and that is much more complicated because as a species, we make things all so much complicated, and you have to kind of overcome that, and it's a slow and difficult process, and so that is a real critical challenge. And for all the other challenges that face Floodmore, scalability and measuring and water quality, protecting water quality, and the list goes on. You can look at the DWR research plan, and they talk about the different things. The most critical one is most difficult to overcome, and it requires concerted effort by people is working through water rights. So questions to the group, I guess.
Well, we're Okay, thank you. Ooh, I gotta move this down. Thank you so much. That was a lot of information, but I'm really looking forward to the discussion. Let's give these three another round of applause for those great presentations. A ton of information, kind of moving from the big picture background down to some really specific examples in vineyards within our basins. And I just want to kind of harken back to something that Marcus mentioned about, this is not just vineyards or agricultural lands. There are opportunities for recharge all across our landscapes on many different land uses. Resource conservation districts, I represent the Sonoma RCD, and Brittany's here with the Goldridge RCD, can help particularly rural and ag landowners think about recharge and managing rainwater and stormwater on their properties. For homeowners on smaller parcels, Kamyar did a great thing where he had examples of the handouts and he held them up. I wish I had done that, but I will learn that for next time. There is a brochure on the table that gives some great ideas for things that homeowners can do on their own properties, everything from simple to a little bit more complicated. And then there's also an example of a more detailed publication that you can download online. So really, we're all in this together. There's something for everybody to do, and so I encourage you to take a look at that information. We've heard a lot about opportunities. We've also heard quite a variety of challenges, but I think we all know that recharge is important to sustainability in our groundwater basins, and so that's why we're all here together to talk about how we can meet those challenges and figure out how to make more recharge happen in our basins. So that brings us to that kind of spirit of working together to figure out challenges brings us to the more interactive portion of our evening. We'll start with kind of questions from the audience and answers from our speakers. I'll come down in a minute with microphones, and maybe Ann or Andrea can help me with this, because I think we have two wireless here. And spend some time on question and answers, and then after that we'll move into smaller group tabletop discussions where we'll have the chance to really collect more questions, collect feedback from everybody who's here in attendance today. So as I walk down with microphone, we left off with that one needs to be turned on, buttons on the bottom. There was one question earlier. I think the question was, does California tiger salamander help with recharge? Was that the question? Okay, great. So we can kick off with that one, and then we'll bring microphones to you all.
So with respect to that question, I'm not a tiger salamander expert, but my understanding is most of their habitat is associated, especially here in the Santa Rosa Plain, with areas of vernal pools. And for the most part, those vernal pools form because there's some shallow clay layer or hard pan that captures that, the water as it's infiltrating and ponds it. So that, by definition, is not a good recharge area because you have that restriction to that recharge. I wouldn't say that that's blanketly true everywhere. That water that's ponding in some cases may slowly percolate down, but in terms of just kind of relative degree of recharge, those are probably relatively low recharge areas.
Hello. Kamyar, my question is about identifying locations for recharge. Marcus, yourself, Phil, all stress that this is key to any type of flood-mar project. To that extent, since everybody's relying on large-scale mapping already done in part by the state, is the state going to be investing in re-updating that information, and will they be supporting basins if they're going to do SkyTem or PoolTem or other things in order to do that type of identification?
So the short answer is yes. The longer answer is that the SkyTem technology is fairly recent, and the state DWR is actually piloting this technology on a small scale to make sure we understand its strengths and limitations. And very soon, from what we're learning from that pilot project, we want to do a much broader application or survey of the groundwater basins in the state. So I can't give you a date certain, but within the very near future, the state will make that information available to all the GSAs so that we can improve on the aquifer characterization, which is an important factor for determining where to do managed aquifer recharge and how that relates to existing land use.
Thank you. I just want to ask folks too, if you have a question in mind, maybe shoot your hand up. We have our next question here, but shoot your hand up so we can get to you with a microphone in between questions. So,
I guess a general question to the panel. One of the largest contiguous areas is the Laguna de Santa Rosa. It's 31 miles of floodplain. And has anybody started to look at that for potential recharge basins, since it's tens of thousands? I mean, Dr. Bouchard, you mentioned, 60,000 acres of agricultural land available, but I'm sure the Laguna's got at least 20 to 30,000 acres that is unfortunately managed by federal, state, and local agencies, but it's pretty much public lands as opposed to individually owned. And I was wondering if anybody's looked at that as a potential huge recharge basin, since it does affect the Marquess Creek and the Russian River, both. And it goes through, the heart of Cotati to Santa Rosa, right through Forestville.
Yeah, so the Laguna de Santa Rosa, its location in the basin is that it's actually the location where most of the groundwater flows towards that basin. So it's actually primarily a discharge area. That's where groundwater kind of comes out, seeps into the laguna during most times of the year, and provides some of the base flows and water in that stream. So it's not in the best area for recharge, and also because it's kind of a slow-moving, shallow stream, you have a lot of silts and clays that have been deposited in that area that can limit recharge. But again, because of the scale of it, in some cases it does provide kind of a recharge function, particularly when we have really big floods and the Russian River can actually kind of back up into and form backwater into that area. That water likely spreads out in areas that maybe are a little more permeable and may provide some recharge. But in terms of looking at the basin as a whole, that's kind of one area that we've kind of screened out from looking at kind of large-scale recharge possibilities in areas. But again, you know, kind of looking at some of the results that Phil found up at Sara Lee is even if the recharge is not, you know, benefiting the larger groundwater basin or deeper aquifers, it can still help provide base flows in those streams, which is critical to many of our streams.
Yeah, I'll just add to that and talk a little bit about location again too, as far as the work that DWR is doing with regard to geophysical modeling. I mean, when you or data collection, when you consider this area and look at the potential for recharge, I mean, under Sigma, a lot of like this farm-based recharge is really going to be about stream flows. You know, there's only a very small subset of areas that have good connectivity between the shallow and deeper groundwater, and so if you're in the valley areas, you know, you're probably going to be looking at stream flows, and in that you might get some benefit of reduced groundwater pumping if it's in ag land and you're able to affect your irrigation demand. So I think that's pretty well established in this area, and if Marcus wants to contradict me, he's more than welcome to. He knows it better than I do regionally. There's also, you know, opportunities potentially to do recharge sort of out of the valley up in the higher elevation areas if you can start slowing down your flows from those places and hold back water through erosion control measures. Then you may come into some areas that are kind of more alluvial perhaps and able to provide recharge that gets into the deeper groundwater. So those are some thoughts on location.
The only thing I would add is as we characterize our soil and geology and think about floodmar type approaches, an area that may not be prime for recharge could actually be a good detention basin. So part of this is capturing the flood flows, and then if provided there's a way to convey that water later to agricultural lands or working lands for recharge, and then what you need is conveyance infrastructure. And that's where I actually think one of the biggest potential sources of partnership and funding for floodmar approach is from our flood management community. Because once people do the climate change vulnerability assessments, you're going to be very alarmed at the flood risk that our river systems are going to experience in the future. And we're going to have to get out in front of that flood risk. And we could try to hardscape our way out of it, but that would prevent a lot of these opportunities to get multiple benefits from that water. And so that's why I really think a good, in addition to aquifer characterization, doing those climate change vulnerability assessments will really provide the new base data, base flows that we're going to have to plan around and for. And that's why detention basins, recharge areas, and conveyance facilities. So the flood folks could actually help cost share the construction of these conveyance facilities from the river systems to the working lands and make them available for recharge.
A quick question. Are there some simple rules of thumb about the limits of wine grapes sitting in water, like in terms of depth or how late in the year or the physiological state of the vine? Just curious about that.
I'll talk to that. So we know that wine grapes can take water for a long time. You know, they can take them into May. But that being said, and so like the stuff in the Central Valley, we have wine grapes that have, you know, been flooded into May from March to May, and then over irrigated for another couple months, and there was some management of potential, molds and stuff, some extra applications of sides for that. But I am surprised that nobody laughed when I talked about Central Valley grapes, because we know that they're not the same grape, right, as what you grow here. And so, when they're grown to be fat and to fill up sort of the space, and the grapes here are not. So, here we need to sort of step forward a little more slowly. And like at Jackson Family Wines, we put water on there into April, sort of over-irrigated with the impact sprinklers. And we didn't really have standing water because the soils here, can only infiltrate so fast. And so if we had standing water, it would have flowed away. So we did that. But then looking at the next year, where the next year was really wet, soil moisture conditions in that year were higher and moisture and for a longer extended period of time. And they had been growing grapes at that field for a long time and fairly successfully. And so our Floodmar or RAU or OFR application on that site got nowhere near this sort of an atypical rare condition. And so I think that, you need to be sort of cognizant of what your conditions have been and what kind of soil moistures you can kind of tolerate and for how long, and then you can kind of work within that framework. And you can see, you can push it a little bit and see what your results are. And then I think over time, people will get a better comfort level with it. But, there's a lot of different grapes grown here, and you don't want to lose their value. So.
I think the next question is also for Dr. Phil Bachand, and you went over the slide really quickly, but it was a slide, I think, of the Kings project where there was a couple phases. And just looking at the aerial photograph you had, that looks like a lot of landowners. And so I was wondering if you could kind of go through, I work for a resource conservation district, so I'm thinking, like, how did he convince that many people in a contiguous area to flood their fields at the same time, at the same rate? So I'm just curious if you could just talk a little bit about that process.
Well, we started with having a whale. That's a term for, the big guy, big person, big farm. We started with a whale in Terra Nova Ranch. And that area, unlike this area, had groundwater levels dropping for a long time. And they were down at 200 feet and still are at 200 feet. It was ground zero there, and they had been looking at ways of trying to address that problem for 20 years before I showed up on the scene. And with support of the NRCS, we proposed this idea of broader and wider flooding and moving away from basins. And they were open to the idea because they were worried about their farming sustainability and people. And there were, it's a fairly tight-knit community. There's a lot of landowners there, but those farms are pretty big. So in like the phase 2 area, it's approximately 20 or 30 landowners, over a 7,000 acre area. So, farms are, pretty large. And because of that sort of history of trying to address that problem and the fact that Terra Nova was so interested and had a good network developed, a lot of people came on board relatively quickly. We did outreach, we did presentations, we did our project, we showed that, it hadn't caused the world to collapse, that it had been managed, that we had, we recharged 4,000 acre feet during that demonstration project with a really small turnout and a lot of glue and duct tape. And so, that was, pretty promising. And so then Sigma came along, and once Sigma came along in that area, and they're all critically overdrafted areas, then a lot of local funding support came along. But, it's like anything else, if people aren't interested, they're not going to do it. And so, it's, I may not be here again, But, you know, if I am, it's because people are interested in it, in this kind of work, and that's up for the community to decide. And of course, Sigma is here and kind of nudging people in a direction of like addressing groundwater overdraft. And so that certainly helps that process. But, you know, even with that, you know, it's better if people are willing and interested than not, so.
Could I just add a couple of points? First of all, Don Cameron is the owner of Terra Nova Ranch, and he's the president of the State Board of Food and Ag. So he's got his foot in the policy as well as the grower community, and he's been the early adopter. In fact, I've dubbed him the godfather of Floodmar. And it was in the mid-late 1990s when he was beginning to do this on his own land, and based on his own testimonial, his neighbors thought he was crazy when he was starting to pond water on his vineyards. And he demonstrated to them and others that this can be done in an appropriate way and help the groundwater. Now, the other neat thing about the McMullen project is they got $10 million from the Department of Water Resources Flood Management Grant Program because the purpose of that project is stated to be flood risk reduction, not groundwater recharge, which is an important and ancillary purpose. So again, here is a really good example where if you're you know, pushing the envelope, you can go out and get funding to do these kinds of projects. The other thing is I'm going to loan my rose-colored glasses to Phil, because I do think while, and I said that the larger the footprint of Floodmar, the much bigger benefits we're going to get. However, that doesn't mean we have to wait till we get there. We can do Floodmar one farm at a time. In fact, even from this year, if farmers were to just keep their irrigation ditches full the entire winter, you're doing Floodmar. Without any new permits, without any new requirements, just keep ditches full and use that to begin recharging your groundwater. If everybody did that, that incremental amount of water will add up, and it will make a difference.
This is a great discussion. We have just a few more minutes for questions, and we have two folks with microphones waiting to ask the last two questions. So I'm going to ask the speakers with all of your amazing knowledge to be as succinct as possible with your answers to these last couple questions so that we can make it into tabletop discussions.
The examples that we've seen in the slides were of basically flat areas, and most of Sonoma County's agriculture is hilly, especially the stuff that's permanent crops, grapes and orchards. And I was wondering if there are effective groundwater recharge strategies for those more hillier slopes.
That would mainly, I think you'd mainly try to do similar approaches that you do for managing stormwater runoff from those areas. And, you know, the direction you grow your crops, as far as the rows, you know, how you manage your soils, if you have areas to retain water and slow runoff down the hill slopes. I mean, it's much more complicated. It's more complicated to implement, and it's really more complicated to measure. But those are the approaches that you would start with.
Wonderful job talking about the Floodmar as well as the recharge above use. Both of those techniques are they're very active above the surface, but they're very passive in the actual recharge process. Marcus, you mentioned early on about banking. Can you quickly just describe the challenges that we face if we try to consider a direct recharge process from floodwaters?
Are you talking about like a direct in terms of recharging through wells directly into an aquifer? So when you're recharging through wells, it does, you know, there's a benefit to that in that if you do have shallow clay layers, you can bypass those and get that water directly into your aquifer. It could also allow you to recharge a deeper aquifer. For example, in Sonoma Valley, we're seeing groundwater depletion in the deeper aquifer system and not so much in the shallow aquifer system. So that's an area where recharge is really needed. But there are additional challenges with doing recharge through wells. You know, some of it is related just to the cost of the construction of those wells, as well as the maintenance. They're really prone to clogging unless the water quality is really of a high quality water. And then there's also the permitting aspects. When you're doing recharge through a well, you're kind of into a new permitting regime through the state water resource, the state regional water quality control boards. And so those are things that need to be considered. The work, the pilot studies that we've done with respect to doing recharge through wells, we've done one in Sonoma Valley. And with that, we were using essentially drinking water from our Russian River system that would normally go to people's taps. So it's really high quality water that we recharge through wells and carefully monitored, and it's a successful program. It's something we may explore in the future, but there definitely are additional things to consider and potential constraints in doing, you know, recharge of like stormwaters through wells. Not to say that it can't be done, but there's definitely some additional costs and considerations that you need to take into account.
Thank you very much. So now we're going to move into our next phase of our discussion, which is tabletop discussions. So anybody who is not sitting at a table, I encourage you to do so, because that's where the action is going to be during this segment of the meeting. The tables are themed by basin if you have a particular basin you're interested in, or you can sit at any table you want.